Try to get this done as quick as possible. I'll have out your calculators also. Number 1, when estimating a population mean, are you more likely to be correct if you use a point estimate or an interval estimate? Which one's going to be better?
Interval.
Interval. How come? Bigger range, wider range. If you just do a point estimate, then you're just saying, all right, 7. That's what we're guessing. Well, the chances of it being 7, not very likely. If you do an interval, 2 to 12, better chance that it's going to fall in there. Number 2, newspaper reporter reports that the results of a survey and states the results of a survey and states that 45% of those surveyed responded yes, with a margin of error of plus or minus 5%. You ever see stuff like this when they tell you something? Like if you're watching an election, they'll say, chance of Phoenix getting the vote is 46% plus or minus whatever. That's telling you a range. So in this case, let's write it this way. If they said it was 45%, said yes, what's the lowest it could go down to? 40%, what's the highest it could go up to? That's what we're doing there. We're saying it's in that range. You guys probably don't remember because you're young, but when Donald Trump got elected president over Clinton, Clinton was expected to win by a whole bunch. She won the popular vote, but she was expected, it wasn't even supposed to be close. All right? But as I was watching some of the stuff, and they'd say, oh, in Arkansas, all right, I'm just making up statements. Alaska, I don't have any idea what. In Alaska, Clinton should get 42% of the votes. But then it said crap like this. Plus or minus 20.
That means they can't make a mistake.
So, exactly. I mean, they were right.
Like a meteorologist, they're like 40% chance of rain plus or minus.
But that means that she could get down to 22% or up to 62%. And guess what ended up happening? She ended up on the low end on a whole bunch of them. And she ended up getting beat. So you got to watch out when you're looking at stuff like that. Number 3, given the sample statistics, which level of confidence would produce the widest confidence interval? Explain. Which one's going to have the widest range? 99%, which was what? D? Is that right? Remember, the higher percentage you get, the wider you're making your interval. Number 4, you construct a 95% confidence interval for a population mean using a random sample. The confidence interval 24.9 to 31.5. Is the probability that the mean is in the interval 95%? The answer is no. It's not the probability it's going to fall in there. It's that we are 95% confident that the mean falls in that interval. All right, so it's not saying 95% of the time the mean's going to fall in that interval. It's saying if we have this range, we're 95% confident it's going to fall in there. Now, how can we say 95% and not 100%? Because we always want to be what? Right. And then if it does fall outside, then Riley can say, well, I told you there was a 5% chance it wasn't going to work. Number 5, on some of these are the ones I wanted to make sure, some of them that we went over. It says find the critical values. We need this chart. Number 5, they want C equal to 0.80. That's a pretty easy one to find. What's our z-score for 0.80? Well, it's right down here in the bottom. What's it tell us? 1.28. That's our critical value. So that one's pretty easy because it's right there on that little chart. And we're going to use that little chart most of the time, but not all the time. And this is the part I didn't really go over well last time. The next one says C is 0.85. Is that on the little chart? So what we have is we have this. That's our interval. We want what percentage to fall in this area? 85%. What's that leave for the other two, the two tails here? Total. Just give me a total. 15%. Now we got to split that in half. So how much is going to be in this tail? 7.5%. In this tail? 7.5%. Now 7.5%, we got to bump this over 2 places. So the area that we're looking for is 0.075. What you have to do, and we're not going to do this very much, all right, most of the rest of the chapter will be taken from this little chart right here. All right, most all the time we're going to be 80, 90, 95, or 99, but every now and then, probably just because I like you so much, Brendan, every now and then I'll throw in one that you'll have to use the chart on. And all we're doing is finding that area right there, the area that's in one of those tails. So 0.075. Looking through all this, and I don't have my glasses, so I ain't going to be able to see it. Find something that's closest to 0.075.
There's a 0.0749.
Where's it at?
Negative 1.4 and 0.04.
So negative 1.4, and we just add that 4 to it, right? So what that tells us, it's a negative. We don't really need the negative because this one's going to be the negative and this one's going to be the positive. So we don't really care about that. Our critical value is just going to be 1.44. Number 7, 75%. We do 75% in the middle here. How much is left over for the two tails? 25. What's on each half?
12.5.
So 12.5%. We change that to 0.125. Somebody help me out. What's 0.125 is our z-score? Again, we have to use the chart here.
Negative 1.16.
Anybody else get that?
No, 1.15.
1.15? Is that the closest one?
Yeah.
That's our critical value, 1.15. Number 8, 97%. Do I need to keep drawing the little thing? I'm running out of space. We got 97% in the middle. How much is the two ends? 1.5 each. So that's 1.5, that'd be 0.015. We look that area up on our chart.
That's on there.
What's that tell us?
Negative 2.17.
Anybody else get that? 2.17?
Yeah.
That's our critical value. And I only put the positives on here. It should be, if we were looking at our thing here, that this one would be a negative, that one would be a positive. But when we're just doing the critical values, we just need the positive answer. Number 9. Guaranteed quiz next time. And it's going to be like 9 20s down there, some of the same stuff. Well, no, maybe not 9. Because 9's finding the sample error. Remember, sample error is just equal to x bar minus mu. Somebody help me out. Do I have to write it all down? What's x bar for number 9? 3.8. What's mu?
4.27.
4.27. Somebody tell us our answer.
Negative 0.47.
Everybody agree with that? Number 10, same thing, right? What's X bar for number 10?
9.5.
9.5, what's mu?
8.76.
What's that give us?
0.74.
27.4, everybody agree with that? 11. Let's see, what are we subtracting on 11? X bar is 26.43, mu is 24.67, what's that give us?
1.76.
Everybody agree with Sean, 1.76? Yes, no, maybe? Are y'all agreeing with him just because he's smarter than all the rest of you?
Well,
He is top 5%.
You got
for a reason.
Maddie in here.
Yeah, and Maddie said yes.
Alright.
Incredible sources.
Number 12. X bar is, I'm not sure why they turned it around on you this time, I think just to confuse you. X bar is, I guess some of them they did the other way, didn't they? 46.56, mu is 48.12. What's that give us?
negative 1.56.
Everybody agree with that?
Yep.
Now you can't just agree with it because Ben said it this time.
I agree with that. That's what I have on my paper.
Alright. Just wanted to make sure, Ben, I couldn't trust it unless Sean told us.
Yeah, I would trust Ben.
13, just kidding, Ben. Find the margin of error. Margin of error, this is the formula. E equals the critical value times sigma divided by the square root of n. You got to know how to do this. You got to be able to find the margin of error. For this one, let's wait on the critical value. Sigma. They probably didn't tell us sigma. They probably told us what?
S.
S. You're going to put that in its place. We usually don't know sigma. So you just put S in its place. What did they tell us about S?
5.5.
Say it again.
5.2.
5.2. What was N this time? 30. Now, the critical value here, that's where we got to go back to our chart. This is number 13, right? 95, it's down here on the bottom. What's it say to use for critical value for 0.95? It's 1.96. When you're doing this on your calculator, just type in 1.96 times 5.2, hit equals, and then hit divided by the square root of 30. What's that tell you?
1.86.
1.86. Everybody agree with that? So that's our margin of error. That's how much spread we're going to have. 14. Do I need to keep writing down the formula every time?
No.
Hopefully not. What's S this time? 2.9. What's N this time? And this time, the critical value, they tell C is 90. We look on the chart here. What is it for 90? 1.645. Multiply this times the top, it equals, then divide it by square root of 50. What's that give us?
0.675.
Yep.
That's our margin of error. E, this time they say 80. So I look on here, what's the critical value for 0.80? 1.28 times what they tell us S was this time.
1.3.
1.3, what they tell us N was. 75. Do all that on your calculator, what's that give you?
0.192.
0.192, anybody else get that?
Yeah. Good job.
I'm gonna do 16 up here so I don't have to bend down.
Ben, you got something.
16. Yeah, this time they didn't, the critical value, they told us 0.975, and that's not on our little chart. Fits. .975 in here. How much is left for the two tails?
2.5%.
2.5%, so what's gonna go in each tail?
Or
0 to
If it's
1.25%.
1.25%, and change that to a decimal, so it'd be oops, I moved it too many places, sorry. 0.0125. We looked that up on here.
2.24.
2.24.
But negative.
It's a negative, we don't need the negative here because of what we're doing, so we just do 2.24. What they tell us S was this time.
4.6. Yeah.
And what's N?
1.0304.
Close enough. Everybody got all those?
Yep.
Seventeen. 17, 18, 19, and 20 just says match. We could do a little math and match them up. I wouldn't. When I did it, I didn't do any math. I just looked at them. Looking at 17, 18, 19, and 20. What do you know about 17? As far as if it says 0.88.
That's the smallest number.
It's the smallest. So it's the smallest interval. Looking at your intervals there, which one has the smallest range? C? Everybody agree with that?
Yeah.
So that's C. I did that one first when I was doing these. I did that one first, then I jumped down to this one. Why'd I jump to this one?
Because it's the second.
It's the biggest. Alright, so I looked at 20. Which one's the biggest, has the biggest range down there? A, everybody agree with that? Then I just went backwards. Which one has the next biggest range? B. And then that only leaves one. What's it gotta be then?
D.
D. 21, you might want to watch closely on these. I mentioned the quiz last time, 21. And some on the next page. It's going to be what the quiz next time is going to look like. Says, construct the indicated confidence interval for the population mean. If convenient, use technology. Didn't tell you how to do that, so you can't do that.
I Googled it.
You did? Knucklehead.
You didn't teach me how to do it.
I know, because I didn't want you to use technology. So on this, they tell us C is 90. Grab your paper there. First thing we gotta find is we gotta find the margin of error. If it's 90, what's our Z-score critical value?
1.645.
1.645 times, what's our S this time?
1.5.
What's our N this time?
50.
50? Figure that out for us, what's that?
.35. Oh, .349 then.
Now the book tells you different stuff than what I do. On these, I go out 3 places every time. They say go out different for each problem. I don't like doing that because that just confuses me. So I just go out 3 places every time. Now to create a confidence interval, all we're going to do with this E, on this side, we subtract it. On this side, we add it. But first we need to know what our X bar was. What was our X bar? 12.3. Everybody agree with that? Minus 0.349. And then on the other side, 12.3 plus 0.349. That's how you're going to make your confidence interval. If I get this first side over here. other side?
12.649.
That's our confidence interval, and I'm gonna erase it here in a second so I can do the other, so I don't have to keep bending over. What that's telling us, what was our C again?
0.90.
0.90. So we're saying with 90% confidence, they didn't ask us to do all this, I'm just doing it. With 90% confidence, we can say that mu, the mean of the population, is between 11.951 and 12.649. That's how we would explain it. All right? This is the answer that they actually wanted. $22. What's it say this time? 0.95?
Yeah.
What's that give us for our critical values?
1.96.
Times, what's S?
0.8.
What's N?
82.
Somebody do that for us.
0.173.
Everybody agree with that? 0.173. What'd they tell us X bar was this time?
31.39.
So we're gonna take 31.39 minus 0.173, that's what goes here. What's that give you?
31.217.
And then we're gonna take 31.39 plus that, what's that give us?
31.563.
That's our confidence interval. Again, we are, what did this one say, 95%? We are 95% confident that the mean of the population is gonna fall within that interval. $23.99. What's the Z, the critical value for 99?
2.575.
What's our S this time?
4.7. I'm sorry, 2.14.
2.14. What's our N?
45.
Somebody do all that for us.
.821.
Our X bar this time was 10.5, is that right?
Yeah.
It's 10.5 minus that.
9.679.
10.5 plus that.
11.321.
Again, we're going out farther. If I looked up this answer in the book, it would probably say 9.7 to 11.3. We're going out farther than what the book actually wants us to go out, but it's not hurting anything. Next one, E, again, for 80, was that 1.28?
Yeah.
What's S this time?
4.7.
N,
100.
what's that give us?
0.671.
X bar this time was 20.6. It's 20.6 minus that.
19.999.
20.6 plus that. Is that right?
Yes.
21.201. too hard so far, Brendan?
Yeah, extremely complicated.
Some of your
But I'm with you.
some of your road friends thought it was too hard, I guess.
Yeah, she's gotta be called sleeping girl.
No, because Jackie's not gonna sleep anymore, right?
Micro.
I never
Because she's
Michael
literally
don't
a
sleep,
ball
but
of
Michael's
energy
an outlier.
in every other class, but she makes it
Yeah,
seem
an
out
outlier.
like a light.
That is not
Yeah.
true. I literally just slept.
No, Kaden.
Oh.
Yeah, before class even started, she was over here like yelling and beating me up for no reason at all.
She is sleeping.
And she, yeah, passed out now.
I wanna watch this CD.
How is she possibly passing his class if she sleeps?
She learned that from Matt. Did Matt ever
don't
sleep in
add
here?
up on that.
Ebersole.
Huh?
I watch this CD.
Did Matt told
This
her?
might be
Yeah.
a secret class. No, Mr. Adam.
Elementary statistics.
Alright, these are the ones. I think this is what the quiz is like next time. I think I was lying to you. I think on the quiz I didn't make you go this far. I'm pretty sure the quiz is more like this. They want you to find, it might have something like this, I can't remember. This is your interval. They want you to find X bar, and they want you to find E, the margin of error. The way you're going to do this, nothing hard about this, you just got to keep them straight, know which one to do what. To find X bar, you're going to add the two numbers and divide by 2. To find the margin of error, you're going to subtract the two numbers and divide by 2. It's that simple. The only thing I would tell you, make sure you put the bigger number in front. So you're not getting, you shouldn't get a negative for any of these. What do we get for X bar this time? Now, before I go any farther, that's 13.4. Before I go any farther, so that Daniel can make sure, some common sense stuff here, he can make sure that he's doing it right. That 13.4 should fall where in this interval? It should be right in the middle. So if your X bar doesn't fall right in the middle, then you probably switched them around. You got them backwards. All right? What's this give us? 14.8 minus 12.0 divided by 2. 1.4. Please make sure, the other thing I should say, when you're doing this on your calculator, can you just type it all in? If you type it all in, the calculator is going to divide this last number by 2, then add or subtract that number from it.
Let's make it a fraction.
It's going to, unless you do something like this and put parentheses around it and do all that. Do the top first, hit equals, then hit divided by 2. Does it make sense for the margin of error to be 1.4?
Yes.
Yeah. So if we look here, is that about 1.4 out that way, and is that one about 1.4 out that way yet? 26. Do I have to write all these down, or can we just do them? Just do them on the calculator. So on 26, 30.15 plus 21.61, it equals, then divided by 2. What's that give us for X bar?
25.88.
Everybody agree with Ben on that one? Then take those same two numbers, and instead of plussing them, subtract them and divide by 2. 4.27, everybody agree with Jackie on that?
Yeah.
This is your X bar. That's the mean of your sample. That's the margin of error. Anybody get 27 yet? What's X bar for 27?
1.88.
1.88?
Yeah.
What's the margin of error?
0.17.
Everybody agree with those two? 28, same kind of setup, right? What's X bar?
3.16.
Margin of error?
0.016.
Everybody agree with those? Too difficult? Remember, on all this, what we're saying is, we're trying to come up with something about the entire population, but we can't really do something with the entire population. So we're just doing a sample, and we're saying, all right, the mean of our sample is 3.16. That's the mean that we got. And we can't say that the entire population, the mean is going to be 3.16. But we can say that we suspect that the actual mean of the population is going to be within that 0.016, below or above that, with 95%, 99%, whatever. We didn't know on these what our percent was. But with that confidence, that ZC, that's our critical value or our confidence level. Makes sense, Michael?
Yeah, a lot more so than when I was doing the homework.
Set that off to the side. We'll get them here. I'll do something with them here in a second. We'll lose them. Make sure your names are on them. On these notes, we're going to go back over some of the notes from last time, so you can just get out some of the notes from last time and follow along through it. If you see something new, you can jot it down. That's up to you. Yeah, I don't care if Lily writes down every single word or no words. That's up to her, right? You write down whatever you want. She sets and draws pretty little pictures the whole time. That's spectacular. Bad thing is, and it showed up on this past test, she set and draws pretty little pictures sometimes. And
I didn't know the answer. You didn't set that same score.
I didn't know.
Huge. You add that together?
Yeah.
That's a 98.
Wow.
Dude.
Oh my god. That's what I got.
so let's see. Let's do
But I
it.
think, no.
Let's do a little math here.
That's like a 40.
It was a
Like
96
a 40
actually.
average.
So let's do
So,
it.
SIG
I think I
and
got
FIG
five.
combined is.
It wasn't my greatest test result, alright?
Right?
Let's
Hey, Sim didn't even answer them all, so we didn't get
Brendan,
some
facts.
points.
Brendan. Ignore him, because I'm not going to put your name into this, all right? He's the one that brought it up. So, Phoenix and this other person together,
Might as well just name it.
let's do some interpolation here. Interpolation is when you do stuff where you say, okay, yeah, it's about here, then here, and so I'm going to guess we're about here. That's interpolation. Phoenix and this other person together scored a total of that, Phoenix said. Sean scored this. We know Sean is in the top 5%.
Yeah, not 100%.
So,
Hey, don't worry. If you add my score, it doesn't even make it 100.
Alright. Hey, I heard that.
I don't know that that's very nice because I probably weigh more than he does.
You're also an adult.
I'm an adult. What are you
He might
talking
as
about?
He's been working,
Yeah.
he's been teaching a job for 72 years.
You're a very young
He's
adult.
been teaching since he cut went into his tomb, right?
You like just crossed over.
And then he wonders why he scored that on his tests.
I didn't know what I was doing.
Saying bad stuff like that about me. I didn't give him any breaks whatsoever. I was taking off extra points. There was one problem that was only worth 3 points. I took off 7.
So really, what I'm hearing is Phoenix had like a low D.
No, I had a very bad
That's
score.
an F.
All right,
I did.
doing these inferences. Doing these inferences. Sample statistics. We can use a point of estimate. That's what we talked about last time. Please remember, our N needs to be greater than or equal to 30. And it needs to be normally distributed. Or we know sigma, which 99.9% of the time we're not going to know sigma. Right? Every now and then they'll throw in one, they'll say, sigma is this. How they found that, I have no idea, because If you knew that, then you ought to know the mean of the entire population, and so on and so on. So, but every now and then, just for book purposes, they'll throw it in there. Point of estimate, remember our point of estimate? We're gonna use our X bar to estimate what the mean of the population is, to do some kind of inferring on that. To create our interval, we just got done doing all this. This is the mean, that's our point of estimate. And then we say, okay, our margin of error is this, so we subtract it to get one end, add it to get the other end. That's what we were just doing. And you can tell how confident you are that the mean of the population is going to be in there by using your C, your level of confidence. Most of the time, from here on out, I forgot that I threw some of those others in there that you had to look up on the chart. Wasn't that difficult? Okay, we've done that in the past, but I forgot to explain it last time. Most all of them that we do, 90, 95, 99%. We're going to try to be that confident every time. How come we don't want to do something like 60% confidence?
Pretty vague.
And that's pretty vague, or pretty crappy. We're not going to be very confident. Yeah, I'm about 50% sure that this is going to work. Yeah, that usually
That's how
doesn't
Phoenix
go real well.
I wasn't even 60% confident on the last.
I really think I didn't get a single question right.
Yeah, they won't.
When me and Michael
City,
did it, I just kind of went through and I like filled in the answers, not
Yeah, we
knowing
should've
what
left
any
it
of
on
them
the
were.
record.
Thank you.
It felt so
You better hurry up and get it done.
lifted.
That's what they teach.
3. Do it
Oh, that
quick.
ain't gonna be threes. Bye-bye. I can't even get my feet in 3 seconds.
3.
Start telling me, yelling at me.
3.5.
I don't care. Tell them to come in here and talk to me. This is that little chart, and it's actually got 80% on there also. On the front page, your critical value. Remember, for the critical value, we normally just use the positive, but it's going to be a positive and a negative if we're looking at it this way. So we're saying, hey, if there's 95% in here, then there's 2.5% out here and 2.5% out here, and that's the critical. These are the critical values that we're looking at. You only need to find one of them, because whatever one of them is, the other one's just going to be the opposite of that. And we talked about this. Your level of confidence, we just talked about that. And I'm going through this real quickly because this is all the same stuff. You guys know how to do that. You just take half of it. You figure out what's supposed to be in both tails together, then take half of that. Sampling error. Your sampling error, we can't really find the sampling error, but we did on some of them. It's just X bar minus mu, but probably never ever going to actually know what mu is. So you can't really find the sampling error, but what we can find is the margin of error, which is the largest sampling error. Margin of error is the largest sampling error. And that's what we can find. That's our E. And that's this formula right here that we were using about 100 times on the homework there. Sometimes it's called the maximum error, or error of tolerance. When you're doing your interval, you can either write it this way as using the alligator mouse, or you can write it just like this, and most of you are probably going to write it just like this, especially because of the next thing I'm going to show you here in a second. That some knucklehead looked up. What? I wonder how you knew I was talking about him.
Sean doesn't know anything.
Again, remember, we're not saying that that there's a 90% probability that mu falls in that interval. We're saying we're 90% confident that mu falls in that interval. Two big things. Because if we say there's a 90% probability that it falls in this interval, then that means there's a 10% probability that it falls outside the interval, and that's not what we're saying. Most of the time, it's gonna fall in that interval, all right? But we just leave that little bit there, Brendan, so that we can say, yeah, no, we were still right even though it fell outside. There you go. This is how you do the intervals on the calculator. We're going to make up one here in a second because the calculators are different on each one.
It's up here.
I usually don't carry it up there with me. I usually set it on the desk.
That's probably why it's like all crushed.
It's because these stupid things make these cheap bottles now. It's
I
ridiculous.
think you're just a
I'm tired of you goofing that water bottle.
It doesn't run away from you.
I'm not squeezing it. Look, it doesn't matter
Bro,
how I hold it.
That's gross.
It smashes
Never let
just
go.
from the weight of the bottle.
I normally have like
So if I leave it down here, that's
It's
fine.
even
It still
water
smashes.
bottles.
Look at my finger. I'm not putting any pressure on it. It's still smashing it.
You didn't put any air in it. Full air in it.
It's got that big old distillery water jar.
That was twin brothers
You're drinking
from First Block.
distilled water.
Yeah, you
I've
did.
done that. I've drank gallons of distilled
Did they
water.
ate your twin?
Yeah, for sure. What are you drinking distilled water?
No, I think he just refills it up.
They tried to use those.
Yeah, definitely drinking
It has got a
distilled.
slight yellow tint.
It's only slightly colored.
Like, why are you drinking distilled water?
Like, distilled
yeah.
water tastes different.
It's not as bad for you.
I never tried
I'm too much of
water.
you. I drink a lot of it. I drink like 3
That's like-
gallons in 3
You
days.
drank everything and then
Yes, sir.
On this, let's make up something here. As we look down through this, sigma. First of all, you're not going to know sigma. So we're going to say S. Somebody give me an S. 13. Somebody give me an X bar. What's your mean of your sample?
22.
22. Now this is going to be really, really ugly because we used a big standard deviation, so that means it's going out a whole bunch, right, at a time. Somebody give me the size of your sample. Remember, we need to be where?
About 30.
30 or more.
276.
276.
That is
Very specific.
different.
Now, our C level, that's our confidence level. Again, we probably want to use what 3?
90, 95, 90.
Which one you want? 0.95, I heard. All right? Those are the things that we need to know. Grab your calculator. I need everybody to do this because all these calculators are different, and for some reason I didn't change this. You're going to go to stat, over to test, and go down to Z interval. Now, before you push enter, once you get to Z interval, keep going down. What's after Z interval? T interval. Guess what we're going to do at some point? T interval. Then go on down. What's the next one say? 2 sample Z interval. And we'll talk about that. And then you got 2 sample Z interval. Then go on down. You got 1 prop Z interval. We're going to talk about that. Then 2 prop Z interval. So on, so on. I think that's all of them.
Nova.
Nova.
I have a number too.
Very bottom.
Oh, yeah, dude. It's something that we're not going to use right now. It's just another statistical setup. You want me to explain it to you next time?
Yeah.
All right. If you don't do that, then I have to explain it. So, stat, test, Z interval, hit enter. Mine pops up like this, and it just has a screen and it's got all this stuff on it. I don't know, does yours, is that, I know you guys can't see
That's
it.
what mine did.
So it looks something like that. So it's got input data, sigma, X bar, so on and so on, and a list sort of right there. Alright, so the first thing, the input data. The input data, when you go here, we want stats. So you have to go over to stats and hit enter, and then it'll flash on the stats. Alright? If we were doing something in a list, if we put all our data in a list and we just wanted the calculator to take it from a list, that's where we would put in data. You scroll down, our sigma was, we didn't have a sigma. So what did we do? Put in S. So that's 13. Our X bar was 22. Our N was 276. I hit log somehow. 276. Our C level was 0.95. Now some of the calculators, and I don't hear everybody saying it in here, some of the calculators only have choices there, like 0.95, 0.90, and 0.99. This calculator, we can put in whatever confidence level we want. So if it says 0.75, then we can put in 0.75. And then we hit calculate. And it gave you something that looked like this. What did it tell you the first side over here was?
466.
This side?
23, 25.
That's our confidence interval. Alright? Now, if we go backwards, somebody do me a favor. Take these two numbers, add them together, and divide your answer by 2.
It should be 22.
It should be the X bar, right? Now take these two numbers, subtract them, and divide by 2. It should be what?
13.
It should have been 13. No. It should be E, shouldn't it? We didn't find E. So that's going to tell us what did it come out to be?
3.53.
Say it one more time.
3.53.
That's our margin of error. So if we didn't know the margin of error, could we find it? Yeah. We could find it by subtracting those two and dividing by 2. That's our margin of error. So if they ask you to find the margin of error, you can still use your calculator. You just have to go backwards after you use it. On this, again, I'll probably put this on there because I think this is what the quiz looks like next time. How do we find the X bar? What do we do with those two?
Add, divide.
Add them, divide by 2. So 3.28 plus 9.62 divided by 2, what's that give you?
6.35.
That's our X bar. How do we find the margin of error? Subtract them, make sure you put the big one first.
3.17.
What is it?
3.17.
Does it make sense for the X bar to be this?
Yeah.
Where should that be located at again? Right in the middle. And then these numbers should be about 3 away from that. 3 lower, 3 higher, makes sense. You know, find those two, pretty important. All right, with sample size, what we're going to learn is what your sample size needs to be. And we've already talked about this. Your sample size, this here is what we do stuff for today.
This is new.
Yep. Very important. How to find what sample size is needed to make a good estimate. When I was talking a few minutes ago about when Trump and Clinton ran against each other, this is what the people who were doing the statistics didn't do. They didn't make sure that they had a good sample size. They probably just found 20 people and said, that's close enough, and went with it. And that's why they got such a big margin of error. Sorry if any of you can yell at me.
He's on his phone.
No, I'm not gonna yell at you. I understand it's important. That's why you're on your phone.
Create some
You're
really
saying
good
things
things.
important.
It's not really important. My son texted me.
See, that's important. You shouldn't even be on his phone.
Yeah, shouldn't he not be on his phone?
Yeah, he shouldn't even have a good. But he's doing something for a teacher, so that's why he's texting me about things with the teachers.
It's probably like right now and stuff.
Maybe. Yeah, he's not supposed to have it out, but since he's doing it for a teacher, the teacher probably is allowed to get his phone. I'll probably be tired of it. You go to the UD game tonight? Give you the tickets.
Okay.
You know, wouldn't do that to you guys, especially like Dane, there's no way, because it starts at 9 o'clock.
It's true.
Starts at 9.
I can be late for classes other than this one. I just have to pass this in English. Yeah, yeah. I don't know how that's gonna go. We're gonna try though.
I just gotta get like
We're gonna make it happen.
At least the C this
We're
quarter,
gonna
then I
make it
can
happen.
pass the class.
Damn.
So that I just gotta get a C this quarter. and that's-
$400.
I'm done with college. I'm gonna be poor either way.
See, anatomy
It's
is
just more debt. I'm just saying.
Anatomy's such an easy class.
It really is, but like the naps in there are amazing.
Anatomy.
Anatomy.
Thanks, me so.
It's a CCD class. You sit there and he's like, this pop brainstem, this pop not brainstem.
That's
On this,
That's anatomy.
the minimum sample size, when you get this, you're gonna use this to figure out what's the smallest number that you can have to make your numbers really mean something. When you get it, you're always going to round up, just like we did with some of the other stuff. So when you get something like this and it ends up in is 622.315, whatever the number comes out to be, we're gonna say that you need at least 623. Just round up, all right? Again, use S if we don't know sigma. Just doing this one example here. You want to estimate the mean number of sentences in a magazine advertisement. How many magazine advertisements must be included in a sample? If you want to be 95% confident that the sample mean is within one sentence of the population mean, assume that your sample standard deviation is about 5.0. So if we go back to that formula, we want n equals our critical value times sigma divided by E squared. I'm gonna write that down out here so I don't have to try to remember it. So on this one, we say, let's see, what's it tell us here? 95% confident, we grab our chart. N equals our critical value Our critical value, 95%, 1.96 times sigma. What's sigma this time? So that's our sample standard deviation, right? So it's 5.0 because we don't know what sigma is. It's the S divided by E. What's our E? That's our margin of error. Here's where you're going to have trouble when you actually do it for real life or do it for a real problem. They're not always going to just say E equals this. What's the margin of error? How much off do we want to be? 0? It's probably never going to happen.
We can hope.
Anybody can figure out by reading that how much off we want to be?
One sentence.
One sentence. So we want to be one sentence above or one sentence below. So what goes down there on the bottom in this case? 1. And then that's squared. Somebody type all that into your calculator and tell me what you get.
96.04.
What are we going to do with that? Make it what? Make it 97. So we need to look at about 97 different magazines or different advertisements before we can actually have a number that makes sense. So we got all that. Our E was 1, and we did the math, 96.04, round up. So we said about 97. That's your assignment. The first part of the assignment, this. You're going to lay it. Sean, can we use your desk? You're going to lay it right there on Sean's desk. Make sure your names are on those.